In this video, we're going to walk through how to find the circumcenter of a triangle graphically. So the first step is going to be to graph the 3 coordinates that you have that will make your triangle. And once I graph them, I'm going to go in and label them. So here's point A. Then B is at 1, 2. And C is at 1, 4. And then I'm going to connect these carefully so that they form nice straight lines and I can see exactly where they're going. Okay, so now that I have the 3 sides of my triangle, I'm ready to get started graphing the circumcenter. So something really important to remember is that the circumcenter is made of perpendicular bisectors. So the name tells me exactly what I need to do. I need to be perpendicular to the side through the midpoint. So to make it a bisector, it needs to go through the midpoint. So the first thing we're going to do is we're going to find the midpoints. So doing this graphically, we can tell really easily where the midpoint is on a horizontal or vertical line. But if we're a little nervous about that, we can also use the midpoint formula. So remember that the midpoint formula, if you're using 2 coordinates, is where you add the x values together and divide by 2. And then you add your y values together and divide by 2. And that's what makes the midpoint. So we can use the midpoint formula or we can use the visual method. So let's use the midpoint formula for the line AC, and midpoint is represented by a capital M. So the midpoint of AC, to find that, I'm going to use the coordinates over here for A and C, and I'm going to add together their x values and divide by 2. So the x value of my midpoint is going to be -2, and then I'll add together my y values and divide by 2, so that's going to be 3. So the midpoint of AC is going to be at -2, 3, and by looking, that does look like the midpoint. So the way I could do that visually, even though it is not a horizontal or vertical line, it's a diagonal line. To do it vertically, I can think about the rise and the run. So I notice here that I rise 2 and I run 6, and that's going to be important once we get to perpendicular as well. But thinking about the midpoint, to be the midpoint, it's going to cut both of those numbers in half. So my 2 here, my rise of 2, if I cut that in half, I get 1. So I can use that to find where the midpoint would be. Or I could use the 6, and if I cut 6 in half, I get 3. So if I also think about where that 3 is, notice that those 2 things meet at this midpoint that we found through the formula. So when you're finding a formula, or when you're finding a midpoint, you can use either the midpoint formula, or you can think visually about cutting the rise and the run in half. So I'll come back to this slope triangle in a minute whenever we get ready to do our perpendicular line. Alright, so for our vertical and our horizontal segments, that makes it a little bit easier because I'm just looking at one dimension. So for CB, I notice that it's 2 units long, so the midpoint's going to be 1 unit away from each endpoint. And for AB, that segment is 6 units long, so the midpoint is going to be 3 units from each end. So my first step was to find the midpoints. So we're going to find the midpoints and we're going to graph those midpoints. So now that I've got my midpoints, I'm ready to do the perpendicular part. So step 2 is the perpendicular bisectors. So we've got the bisector part, we've got the midpoint ready. To be perpendicular, perpendicular lines have opposite reciprocal slopes. So I'm going to think about the slope of the side of the triangle that I'm looking at. So if I look at AC again, and I draw that slope triangle back in, my slope triangle was rise 2, run 6. So the slope, and slope is a small m, the slope of AC is 2 over 6, or that reduces to 1/3. So my slope of AC is positive 1/3. So to be perpendicular to that, I need to do the opposite reciprocal. So that's going to be negative, and then I flip it, 3 over 1. So the negative 3 over 1 tells me where my line is going to go. So from the midpoint of AC, I'm going to go down 3 over 1 and make another point. So my perpendicular bisector is going to connect those 2 points to form a line. So there's my first perpendicular bisector. So for diagonal lines, we use that slope formula, our rise over run, and use that to help us figure out perpendicular. With horizontal and vertical lines, finding a perpendicular slope is pretty easy, because if you have a horizontal line like you do on side AB, the perpendicular to a horizontal is going to be vertical. So for AB, I'm going to have that vertical line through the midpoint. And for CB, since it is a vertical line, to be perpendicular to that is going to be a horizontal line. Okay, so I have my 3 perpendicular bisectors drawn, and what I'm looking for to find the circumcenter is going to be this point where they all intersect. So the point where all 3 of these perpendicular bisectors intersect is at negative 2, negative 2, 3. And so the last thing is going to be to verify it. So step 3, verify. And to verify that it's the circumcenter is equidistant from the vertices. So the reason it's equidistant from the vertices is that the circumcenter is the center of the circumscribed circle, which means it goes around the outside. So I'm going to do my best attempt at drawing this circle. It's a circle that's going to hit points A, B, and C, and this circumcenter right here, where they all cross, is going to be the center of it. So trying to draw my best circle, using my tools to help me out. Notice that the circle hits points A, B, and C. And circles have a constant radius, which means that it's the same distance from those 3 points. So to verify it, I'm going to use the distance formula. And the distance formula is the square root of A squared, where A is how far it is between your X values, plus B squared, and B is how far it is between your Y values. And I need to do that for all 3 points. So starting with point A, I'm going to use my circumcenter, negative 2, 3, and the coordinate for point A, which was negative 5, 2. And I want to look at how far away each of those points is in terms of X and Y. So the distance between my X values, to go from negative 2 to negative 5, there's 3 units in between them. And I always use a positive number there because I'm going to square it in my formula anyway, so it's going to end up positive. So I have a less likely chance of making a mistake if I use the positive number here. So since that distance was 3, that's my A value. So this is going to be 3 squared. And then I'm going to find how far it is between my Y values. So between 3 and 2, that's 1 unit. So B is 1. So the distance here is the square root of 3 squared plus 1 squared. 3 squared is 9, and 1 squared is 1. So if I add that together, this is the square root of 10. So the length between A and the circumcenter is 10, is the square root of 10. If I was correct on my calculations, this should be the same for all 3 points. So let's look at our next point, point B. So again, I'm using that circumcenter, negative 2, 3, and the coordinate for B, which was 1, 2. And I want to figure out how far it is between the x values and the y values. So between -2 and +1, that's 3 units. And between 3 and 2 is 1 unit. So my distance formula, 3 squared plus 1 squared. Underneath the square root. So 3 squared plus 1 squared, I already did that, so I know it's the square root of 10. So far, these two are equal. So we have one more point to verify. Let's check our distance between point C and the circumcenter. So the circumcenter, -2, 3, again, and then the coordinate for C is 1, 4. So I want to find these distances between the x and y values. Between -2 and 1 is 3 units, and between 3 and 4 is 1 unit. So put that into my formula, 3 squared plus 1 squared under square root. This is familiar, square root of 10.